Hello everybody, I am David Shipley Alexander. Welcome to my Infinite Energy series on YouTube. In my first introductory video, I defined infinite energy as usable energy provided by a non-conventional source. In my second video, I gave background information for LENR, which is an acronym for Low Energy Nuclear Reactions. In my third video, I explained how the extension of LENR to high temperatures could provide a new form of energy for homes, automobiles, and commercial aircraft. In this, my fourth video, I present first a historic connection between NASA and LENR, and then a look at how LENR may enable space travel, for example to Mars, to be more feasible. First, the historic. These are two contractor reports. The first one, and then the second one, which has the label Volume 2 on it. Which I wrote for NASA in the early 2000s. This work is in the public domain, available online, and you can find it by putting in the name I was using then, David S. Alexander, and the title is Advanced Energetics for Aeronautical Applications. These are a little over 100 pages, and this contract came through the NASA Langley Research Center. The work was directed by Dennis Bushnell, the chief scientist at Langley. In 2000 and 2003, Bushnell sent me to investigate LENR research and allowed me to report on other further out concepts, provided I used disclaimers. So the NASA LENR connection goes back at least to 2000. In recent years, Dr. Zawadny at NASA Langley, who I have not met, has presented YouTube videos on LENR applications and current NASA LENR research. Now let's look at the future. With the state of the art, the upper stage of a manned rocket beginning a trip to Mars will not be able to carry much chemical fuel, and therefore coasts in a transfer orbit from Earth's orbit to Mars orbit for approximately 7 months. Not good, due to weightlessness, cosmic rays, which were shielded from here on Earth, and just being in a small place for that long a time. So we ask, what if we use LENR heater tubes that's slightly hotter than 1200 degrees centigrade and transfer heat to a relatively low flow of hydrogen passing over the LENR tubes, and then the hydrogen goes through a de Laval nozzle, standard rocket nozzle, becomes supersonic and provides thrust. Very low thrust to be sure. However, the thrust and acceleration is continuous, can go for days or weeks, not just minutes or seconds. Would this help? I found a rocket nozzle equation, made some realistic assumptions, and calculated that 1200 degree hydrogen entering the nozzle would exit at approximately 6 kilometers per second. Not bad. Then, assuming a realistic spaceship mass and starting with enough onboard hydrogen to provide a workable thrust, could the minimum distance between Earth and Mars, which can vary, but it's about 35 million miles or 56 million kilometers, could this be traversed in 60 days? That's 30 days acceleration, turn the spaceship around, and then 30 days negative acceleration. Important to do that, or you don't want end up being another crater on Mars? And the result was no, not even close. Less than 4% of the distance. So what to do? So I realized that thermal gas velocities are not sufficient for continuous space propulsion. I then looked up information on the Dawn spacecraft, which NASA sent to the asteroids Vesta, and then on to Ceres, where it's now still orbiting. After leaving Earth, the spacecraft had solar panels come out, and that provided 10 kilowatts of electric power. Now that's at Earth's distance from the sun. As it headed out to the asteroid belt, that power went down considerably. Inside the spacecraft, that was raised to high voltage, and that powered what's called an ion engine, which is designed to run continuously. The propellant is xenon gas, which is ionized. Then the ions are accelerated. They go out through a grid-type electrode with a velocity up to 10 times typical thermal velocities. I envision heat radiated from a number of LENR tubes running at approximately 1200 degrees C can be converted to electrical power to run an ion engine on the Earth to Mars spacecraft. In video number 3, I mentioned that Stirling engines are one means of converting heat to electrical power. Another would be thermophotovoltaic cells, which are very similar to photovoltaic solar cells, but are designed to produce electrical power from heat emitted by incandescent objects rather than by the sun. So here is where I place my disclaimer. I have more assumptions to check, information to obtain, and calculations to verify, but so far it looks promising that LENR technology can significantly reduce the travel time to Mars. I'm moving on to other videos. There are many waiting in the queue, so to speak, but I shall return to this one. So for concluding remarks here, in my first video in this series, I referred to the writing of Dr. Peter Lindemann. As he said, and I agree, infinite energy exists, but it has been suppressed. I believe LENR is a precursor to the fully fuel-less infinite energy, but quite in advance with its 1,000,000-to-1 energy-to-weight ratio compared to chemical fuels. In the beginning, LENR was severely attacked for many years. It was only communication and cooperation between people working on it, often covertly, which led to advances in the present useful high-temperature form. This same adult consciousness will one day lead to a more full release of even more exciting forms of infinite energy. Stay tuned. Don't forget, you may leave a comment or question under these videos, subscribe, and leave a thumbs up. Thank you for that. Near the top of my future video queue is one on a very different model of the atomic nucleus, which I believe is worth further study as it could lead to technology breakthroughs. The concern with propellant mass in this number 4 video tells me that propellant-less propulsion should be moving towards the top of the queue. You may ask, how is that possible? How can the spaceship be accelerating without mass coming out the other direction? Stay tuned. Thank you very much for your attention. Until the next time, I am David Shipley Alexander.